Hi, I'm Mitch, Technical Service Coordinator here at Biospherics, and we just want to do a video here for you. We get an awful lot of requests on how to calibrate my oxygen sensor. So this video is going to cover all you customers, and it's the majority of you out there who are operating a controller that has our model E702 sensor. This is what it looks like. And you'll see right on the side it's going to have phone number to reach if you have questions. It'll have the model number E702, and it's going to have a serial number. It's going to be this little black box with a flow diverter tip coming off at a right angle. That tip might be black, might be white. That's changed over time, but you're always going to see a model number on here, and that's how you know what you have. It's going to be found on a wide variety of systems. So whether you're doing cell setup in an incubator with our model ProOx E702 it's going to be found inside the incubator, right on the back there, the adapter plate. Or if you're doing an animal setup with the ProOx model 360, very similar controller, just larger. It's found off to the side on the adapter plate. As you can see, this one has a different color flow diverter, but it's the same sensor, model E702, found right there. Some animal setups have a dual redundant controller for the fail-safe setup. It would just be two of these next to each other, so you would have two sensors, but again, calibration is going to be exactly the same. Or finally, any of our X3 independent series, the glove boxes, they're all going to have a ProOx model 360 as well. Same sensor is used to control oxygen, and that's going to be found in back here on the buffer chamber, right on the adapter plate. So again, you can get tripped up by having different configurations, but the calibration is going to take place exactly the same whether you have a model P360, a model P110, whether you have animal, cell, whether you have the X3 independent line, doesn't matter. Calibration is going to be done exactly the same. I just want to go over kind of the idea behind calibration, why we do it, how often we do it, and then I'm going to show you the different ways that are covered in the manual how to do it. So first off, the idea behind why you have to calibrate. The sensor is an electrochemical sensor, and when it is exposed to oxygen, the chemical inside of there is consumed, it's used up, and it gives off a millivolt reading, and that's what the controller is actually reading. But it eats itself, it eats that chemical up over time, and that causes the sensor to drift. And basically about once a month is what we recommend, is you want to account for that drift. So these sensors, the reading output is linear. So we tell our customers to do a 2-point calibration, a low point and a high point. And you always want to do a 2-point. And the idea is if you do a low at a known standard and you do a high at a known standard, everything in between is going to be accurate. So once a month, it's a good idea to calibrate it. If you're not using it and it's just going to sit dormant for a few months, you don't have to calibrate in between. Just calibrate before you start the next time. The key piece when you go to calibrate is going to be your calibration chamber. It'll look like this if you have a model P110, or it will look like this if you have a model P360. They're exactly the same cup, work exactly the same way. The only difference is because the model P360 is a little larger controller, it has a little larger tubing to it. You're going to find this in the bag kit that comes with the controller. So when you go to set your controller up and you're unpackaging it, there's going to be a little bag. It's going to have some fittings and whatnot. This will be in there. Don't chuck it. It's not you know, an extra piece. It's used for calibration. And again, you're going to find this no matter your setup. You'll have a calibration chamber. That if you do lose it, it's no problem. It can be replaced. You can always get another bag kit. The most common setup is you're running low oxygen, below room level, and you need to calibrate. So what you're going to already have, so that's this setup right here, running low oxygen. Could be the animal setup. I just currently have it set up here. So I have nitrogen hooked up to my controller, and my tank here. Gas is on, and I want to check to make sure I'm getting gas. So I am. You can hear it coming out of there from the bleed valve. Just a turn. And I'm looking at the controller now, and I see it says 20.3. So that's really typical after a couple weeks after calibration. Room air is 20.8. It's a little lower than that inside an incubator when it's all running, but I can already tell it's drifted a little bit. So I want to calibrate. It's my month is up. My room air reading has drifted a little bit, and I need to calibrate. So I have my calibration chamber, and I know I have nitrogen gas, which will be our low calibration. We call it the zero calibration. So I need a high. So the high is going to be room air, because if I open this door up, it's just exposed to 20.8. So that's my second known standard. So I'm going to do this calibration right now. I'm all set to go. So I'm going to hook up the chamber. Just take the end of your tubing, put it right on that bleed valve. You turn that until you can feel and hear it coming out of there. You don't need to crank up the power on there. You can run the risk of over pressurizing the sensor, and that just throws the reading off. If you do that, it doesn't damage the sensor, but about like that, I can feel it with my finger and I can hear it, so I know that's good. I'm going to grab my sensor. So if this is your setup, I just pull the sensor out, pull it forward, and I'm going to put the tip right in there, and then I'm just going to watch the front of the controller. So this is our zero calibration. So what we're doing, we have nitrogen hooked up here. So pure nitrogen is flowing directly over to the sensor. So it should read 0.0. A lot of times it will, other times it'll be off a little bit and we'll have to make a little adjustment. But we just let it run until it stabilizes here. It usually takes about 2-3 minutes. You don't want to let it just keep running. You know, sometimes people will ask us, you know, should I let it run for 20 minutes or what? No, that's way too long. You can see it goes down quickly, stabilizes out. I let it run for about 2 minutes. You know, if I don't see it change for about 60 seconds, I know we're at zero. And it looks like we're right at zero, so we don't have to make a change. Okay, so I wanted to show what would happen if it doesn't settle right at zero. So we've got our nitrogen flowing right over the tip. It's stable. I've let it run about 2 minutes, and it says minus 0.1. That's incorrect. It should be 0.0. It's pure nitrogen. Can't be a minus. So I need to make an adjustment. And to do that, I need to go into the program mode on the controller. Everything's found in level 3 on the controller for calibration. So I'm just going to hold the up and down for 3 seconds until I see the word tune and off. Now I know I'm in the program mode. So I press down once to get to the level function. And I need to change it to level 3. So if you want to make a change to a function, you hold the star, and while you hold the star, you can press up or down. So you can change through the different. So now I'm on level 3, and I want to navigate to 0. I just press up, and there it is, 0. It looks kind of strange, but That's 0. And it alternates with a calibration coefficient. And that number doesn't mean a whole lot. When we're done, I'll kind of explain. But whatever you were off from 0 by, you need to make that adjustment to this coefficient. So we were minus 0.1. We need, which means we were 0.1 below where we need to. So we have to do the opposite to this coefficient. So we need to raise it by 0.1. So I'm going to hold the star, press up once, and then I'm going to save it and exit the program mode, and do that just like you entered. You hold the up and down for 3 seconds. The reading's going to come back. It's now reading 0.0, just how we expect it to be. My gas is still running here. Again, what you want to do is, as soon as you do this, this is where it gets a little confusing. So I'm just going to cover it one more time real quick. Run your nitrogen by. You know it should be 0.0. When it stabilizes, make a note of how far off from 0.0 you are. Because however far you are off, you need to make that opposite change to that coefficient, the 0 coefficient in level 3. So if we had done this and it hadn't been minus 0.1 like we saw, or 0.0, say it was 0.5. Well, we know we're 0.5 above where we need to be, so we would have gone in to level 3, found the 0 coefficient, and lowered that coefficient by 0.5. Whatever you change that 0 coefficient by, you change this reading exactly the same. It's a 1-to-1 change. So that's how you make your adjustment. Now that we're at 0, we're all good. We're just going to turn the gas off by closing the bleed valve. I'm going to take the sensor tip off here. We're done with our 0 calibration. Again, it's a 2-point calibration. A low, our 0, and then our high, span. So now we're going to do a span, our high level, which is going to be room air. So I just wave it around like this, and again, let it sit for about 2 minutes. We have been blowing a little bit of nitrogen here, so this helps clear it out. But as you can see, the reading's going right up. I just kind of wave it around, and what we want is 20.8. It should read 20.8. And it probably won't. The span changes a lot more than the 0. So we'll see where it settles at. And you just let it sit for about 2 minutes here. Okay, so we've let it sit here about 3 minutes now. It's settled. It's at 20.4. We know room air is 20.8. So it's a little too low. And we can get that closer. We need to make an adjustment to our span coefficient, just like we did with the 0 coefficient. Now, the only difference is span is not a 1-to-1. Span's a course adjustment, so you have to play around with the coefficient a little bit to get as close as possible. So what I'm going to do is I'm going to go into the program mode just like I did for the 0 calibration. Hold these for 3 seconds, the up and down. You'll see tune. You can let go because you're in the program mode. And if you press down, you'll go to the level function. And whenever you want to make a change to one of the functions, you just hold the star, and while you hold it, you press the up or down. And I've changed it to level 3. I'll let go of the star. And now I want to navigate through that level, and I can do that by pressing up or down, and I'll just show you. If you pass it by, you just hit down to go back to it. So we're going to press up until we see the word span, S-P-A-N, and the N looks weird, but that is supposed to be an N, and that's our coefficient, minus 68. So because it's a course adjustment, we know that it's not going to be a 1-to-1, so we just have to make small incremental changes and see how close it gets. We were at 20.3, 20.4, we want to be at 20.8 or close to 21. So I'm actually going to raise this by 1 because we were too low. So you always do the opposite adjustment to the coefficient here. So I'm going to hold the star. I'm going to raise it up 1. So I've made a change to that function, and now I want to save that and exit the program mode, so I hold up and down for 3 seconds. And we see what it does. And we're at 20.9. The change worked. We're right where we want to be. If I try, you can play around with it if you want. If I try and raise that another one, or if I try and lower it one, it's going to be too far off. Again, it's a course adjustment, so you get as close as you can. So this is right on the money here, and we're good. Our span is now done. I can take my sensor and put it back on my adapter plate. Close the door, and yeah, some people leave their calibration tubing attached. Personally, I don't. I just keep it stored, so you can take it off and you're all set to run. That's going to work exactly the same as on the animal system or the P360, on an animal system or the P110, or on one of the X3 independent systems. Exactly the same, done exactly the same. You take the sensor from the adapter plate, you do the 0, make your adjustments if you need to, then you do your span to room, make the adjustments if you need to. As you can see, you know, it's actually a little easier on these because your sensor is pretty close to where it needs to be. Same with on the glove boxes. You're just going to run your calibration tubing here, and you've got your sensor right here. You're already in the close area. The one little bit of difference if you're running an incubator setup is that the sensors are, they do have a feel for the temperature. So if you're in a warm incubator, you don't want to take a half an hour doing your calibration. If you do it, you know, exactly like we just did, a couple minutes, it's perfect, it's fine, it's back in the temperature, your calibration's accurate. If you let that sensor sit out in room air after having it in warm for half an hour, the calibration is not going to be quite as accurate. You'll still be okay, but it does have an effect. You don't have to deal with that with the glove box setups, the X3 setups, the animal setups. That's not an issue. It's only with the incubators where you just don't want to leave it sitting there, walk away, take your lunch, then come back and do the calibration. Just do it all at once, one time, within 5-10 minutes, and you're done. So that's how to calibrate if you have a nitrogen hooked up to your ProOx 110 or your P360. Again, any of those works exactly the same. The manual also describes what to do if you have oxygen hooked up, if you're doing high oxygen work, because you don't have access to a 0 gas at that point. So I'm going to cover that as well. Again, it's same setup, or does exactly the same no matter what your setup is. You're less likely to come across the high oxygen calibration with a glove box. It's a little less common. Quite frequently you see that with the animal setup, so I currently have it on an animal setup, so we'll do it real quick on that. But again, these techniques work exactly the same on all of these controllers. So the difference, if you're doing high oxygen work, anything over ambient, you've got pure oxygen hooked up to your controller. You need to do a 0 and a span, 2-point calibration always. Difference is your known gas is 100% oxygen. The other gas you're going to have always access to is your room air, 20.8. So we're going to use 20.8 as our 0 in this case. If you have oxygen hooked up, use 20.8 as your 0. So I'm going to go in, look at the controller, and I see it's reading 22.1. I know I need to make a calibration change because it's reading off from where it should be. It's probably drifted. It's been a couple weeks since I did my calibration. These sensors drift just like normal. I'm going to do it. So to do a 0 calibration, I have my sensor. I'm just going to set it here because it's in room air. I know it's reading room air. It's actually going to go up a little bit here because I moved it. Okay, so we have our sensor out in room air and we're off a little bit. We've let it sit, so I need to make an adjustment to the 0. So I need to go into the program mode. I hold up and down for 3 seconds to do that. Once I see the word tune, I can let go. And I'll press down once to get to the level function. And if you get lost, I just want everybody to feel comfortable going through the levels. You just press up or down and you go through all the different functions. So just press down until you see level. And we need to be on level 3. So I hold the star because I want to make a change. Press up twice. I'm on level 3. And then I want to scan through level 3 until I see 0. And it's minus 1.3 is the coefficient. Again, the coefficient doesn't matter too much. What matters is what you do to that coefficient. So we were about 0.2 over from where we need to be. So I need to lower this by 0.2. So I hit the star and I press down twice while holding the star. And now I need to save that. Exit the program mode. So I hold up and down for 3 seconds. And then the reading comes back. And it's actually a little lower than what I want to be. I can get more accurate. The 0 you can get real accurate. So I'm going to just, and this is typical, I'm just going to do it again. I'm going to hold up and down for 3 seconds to enter the program mode. I see tune, so I can let go. Press down to get to the level function. Hold the star and change it to level 3 by pressing up. Scan through until I see the 0. And so I went too far by 0.1. I got too low, so I need to raise it by 0.1. So I'm going to hold the star to make a change. And I'm going to raise this by 0.1. Save it. Okay, and so we're at 20.8 now. It just took a second to kick in there. So 0's done. We're at 20.8. It's reading room. I'm going to take my calibration chamber, take my tube end, put it right on the bleed valve, open the bleed valve up till you can hear it. I can hear it and feel it coming from there. And I'm going to put my sensor tip right in there and then just let it rise. Let it sit for about 2 minutes. So what we're doing now is we're doing our high end, our span calibration, the second part. And we're exposing our sensor to pure oxygen right now, so 100.0. That AL you're seeing is just the alarm setting being turned on there. It just is letting you know that the alarm condition was reached. And again, the span is a coarse adjustment. When you're using pure oxygen, it's always a little less accurate for a couple reasons. Number one, room air for your 0, 20.8, that's a little less accurate than if you were to use nitrogen for your 0, because room air can fluctuate a little bit, that percentage. Also, the sensors really only read 99.9, and at that very, very top end, it's real tough for them to be super accurate. So we get as close as we can. It's not quite as accurate as if you were going to use room air as your span value. But the idea is, if your set point is above room air, you always want to calibrate your 0 below your set point and your span above where your set point is. So if your set point is set for above room, 30, 40, 85, anything, you have to have a lower set point for 0 and a higher set point for your span. Okay, we've let it sit for a couple minutes here. Again, you just want to let it sit till it's pretty much stabilizes. It's pretty steady here. It's reading 116.3, so we're way above 100% here, which is really common when you do a new sensor, because your span number needs to come down. So we need to make an adjustment to the span. It's a coarse adjustment. It's in the program mode, so we're going to hold up and down until we see tune. We need to go to the level function, so I hit down once, go up to level 3, And I just press up to go through the level until I see span. So I see minus 60 here. Again, it's a course adjustment. You might have to go back and forth a couple times. And when you're doing 100% oxygen, it's always going to have a little bit of inaccuracy. So you just get as close as you can. So we're way above 100. So we need to bring our coefficient down. Since we're above, I'm just going to go to minus 69 and see how close that. So now I'm way too far. I've come back. Now it's only saying it's about 90%. So I need to go back in. Press down for level. Hold the star. Press up for level 3. To span, I need to raise it up because I went too far. Raise it to minus 66. Now we're almost to 99. I'm going to go back in one more time just to show you how it's a course adjustment. This is probably about as close as we're going to get, but we'll take a look here. So I'm going to go back into the program mode, holding up and down. Press down once for level. Hold the star and up for level 3. Over to span. Press up 1. And see, I've way overshot. So I'm going to err on the one that was closer. I'm going to bring it back down 1. There we go. That's as close as we're going to get, which is okay. I mean, that's extremely close. I'm going to shut my gas off. Take my calibration chamber off. Return my sensor. And I'm all set to start using again. I wanted you to get a good idea of how it works at the high oxygen. As you can see, it's not. There's a little bit of back and forth. It's not quite as quick and as accurate as the other method. It does work. It's just as viable to do it that way, but you're just running up against some of the physical limitations of the high end of the sensor and what it can read, and some of the inaccuracies with using room air as your zero. There is one more method that's covered in the manual. I'm not going to actually perform it, but I do want to show you. It talks about doing zero with nitrogen and then span with a mixed gas. So I brought up our mixed gas tank here. And what this is it's 90% oxygen and a balance of CO2. So what we're doing is 2 gas known certified levels. So you do your zero just like we did for the P110, and then you would hook up your mix tank to the controller, and it would be whatever the tag says. In this case, it's exactly 90.0 for oxygen, and you would calibrate your span to 90.0. It's not necessary in these setups. It's just an extra gas. Some people have easy access to a mixed gas, so go ahead and feel free to use it if you want, but as you can see, you don't need it. You can use just the gases you have and do the calibration. Again, yeah, just to recap, the sensor being electrochemical, it needs to be calibrated at least once a month. That's what we recommend. Drifts over time, and if you're going to do a long experiment, before your experiment, it's a good idea to calibrate, and then monthly thereafter. Sensors have a lifespan of about 2 years, so at around that point you're going to see it's going to get difficult to calibrate. You're going to see that span number jump quite a lot. I always recommend keeping track of that span number and the change that you make each time you calibrate. That's going to tell you when your sensor's starting to age, when you see those big jumps in span. At the beginning I said I would kind of talk about the coefficients a little bit, just to give you an idea. The zero on a new sensor usually starts around minus 1.2. Every sensor is different, but that's that gives you a good idea. And you're going to have a setup sheet with your controller that shows you what it starts at. It might drift a little bit from there, but if you ever see a big change in that number, that's an indicator that either the technique you're using to calibrate might be off, or there's something off with the sensor. The span, a brand new sensor, usually starts in the -60s somewhere, and it typically gets more positive over time. So when you see your sensor start reading -40, -30, -20, that lets you know your sensor has aged significantly, and that's a good idea. Change that sensor out. If you see it do really big jumps each time you calibrate, that's also showing that it's aged. Again, every sensor is different, and there are sensors out there, it's rare, that get more negative over time. If you see something odd, or that calibration coefficient seems just really out of line from where it started with on your green sheets, your setup sheets, or what you've been keeping track with, that's your big red flag. Hey, there's something wrong with my sensor. It's either probably time to change it, or it's failed, or if it's a brand new sensor, give service a call here, and we're more than happy to talk you through. But that's how to calibrate your model E702. Again, it doesn't matter what model setup you have, whether you've got the X3 independent setups, C shuttles, iGloves, any of those glove box setups, calibration is going to be exactly the same, whether you're running a cell system, or the P110, or a P360 on an incubator, same exact calibration, or if you're running an animal setup, or the P110, a P360, a dual redundant fail-safe setup, it's always done exactly the same, just like you saw. And good luck, and call us with any questions.